Now, the last example that I'm going to solve, it's going to give me a slightly different result than all of the other ones that I've been solving. I think the PowerPoint shows it x squared plus 2x plus 2. That's a polynomial. As it's written, it's a polynomial, so I'm just going to set it equal to 0 so that it becomes an equation. So I'm going to treat this as if it was an equation to see what situation we're going to bump into in this case. Okay, so my value for a, that's going to be the first number, that's the first coefficient for the x squared, that's going to be a 1. The value for b, that's going to be the second coefficient, it's a positive 2. And the value for c, it's going to be positive 2. Okay, so I'm going to substitute into my quadratic equation, my quadratic formula, excuse me. X equals negative b plus minus the square root of b squared minus 4ac divided by 2a. So I'm going to replace my variables for a parenthesis. It's negative b plus minus the square root of b squared minus 4ac all divided by 2 times a. So I'm replacing my value for b. That's a 2 that goes in the first two parentheses. That's a 2 and 2. Now I'm going to replace my value for for a. That's the second value. The value for a that goes in these two parentheses over here, and the value for c is going to go in this letter c over here, which is the last parenthesis. It's a number 2. So let's see, we can do some PEMDAS to this, try to solve the operations. So it all starts with a negative 2 plus minus the square root of 2 squared, that's 4. And then the operation that I'm going to do in here, can you see that's going to be negative, right? Negative 4 times 1 is negative 4, times 2, that's negative 8. So the result over here is going to be negative 8. Okay, and then use the multiplication on the bottom, divide by 2. If you keep going, I'm going to do the operation inside the root. That's going to be 4 minus 8. 4 minus 8 is going to be negative 4 divided by 2. Now, can you see we're going to run into a problem in here? Because this doesn't have a result. Square roots of negative radicands or negative numbers inside square root sign, they don't have a result. So we're not going to have a real result in here. However, we can simplify this this expression or this operation a little bit further. So let's see if we can do something to this root. Since we cannot take the square root of that number, let's see if we can simplify it somehow. So can I split this? Let's treat it as if it was any other square root. Can we split this into two square roots or two products, two factors, such that one of them is the greatest perfect square? So again, my perfect squares, it's 1, 4, 9, 16, 25, and it keeps going. Right? So which of these 5 numbers is the largest? The largest number that is a factor of negative 4. So can you see that you can split this root? You can split it into 4 and negative 1. That we can do. Right? Because 4 times negative 1, if you multiply those two, you get the previous radicand as a result. So we can do this, right? We can do this. Let me get rid of this perfect squares. So if I simplify this expression, what is this going to look like? 2, because the square root of 4 is 2, and then square root of negative 1. So it means that we can simplify this a little bit more. Now, this is what we call the simplest imaginary number. So we don't have the square root of negative 1, but we cannot simplify this further. So from now on, this square root of negative 1, we're going to replace it for a letter I as in imaginary. Okay, so every single time that you have a negative root, you can just call that I, whatever. If it's the square root of negative, let's see the square root of negative 36. Since the square root of 36 is 6, then we're going to call this 6i. If you have the square root of negative 49, since the square root of 49 is 7, we're going to call this 7i. And then you can keep going, right? The square root of negative 100. Since the square root of 100, of positive 100 is 10, we're going to call this 10i. And so on and so forth, right? And we have the example that we're doing right now, square root of negative 4. The square root of 4 is 2, so we're going to call this 2i. So this whole thing over here that we're simplifying, we're going to call it 2i, and we're going to replace this 2i for the root in the formula, the expression that we're simplifying. So negative 2 plus minus, we say we're going to replace the square root of negative 4 for 2i over 2. And at this point, we should be able to simplify these three whole numbers like in the second example, I think it was. Okay, so what are all of those three numbers divisible by? All of those are divisible by 2, so it means I can divide all of those by 2. The first one, negative 2 divided by 2, that's going to be negative 1, plus minus, and then 2 divided by 2, that's going to be 1. I'll leave the I in there. Remember, that's the square root of negative 1. And then on the bottom, 2 divided by 2, that's also 1. So just to simplify a little bit more, 1 times I, it makes no sense I put 1i, I can just put I by itself. Then I don't really have to divide by 1. So I can say that this is my result. These are my two answers. These are my two answers. This is how you're going to look for it in the handout. So when you see a negative root, or when you arrive or bumped into a negative root, just don't panic. Just take the root as if it was a positive number and then give it an extra I at the end. Okay. So we have situations like square root of negative 11. We know this doesn't have a square root, or 11 doesn't have a square root either, right? So I'm going to split this the same way. I'm going to split it into two roots. Okay, so that's a negative 1 and 1. This is not going to lead us anywhere. Okay, this is not going to lead us anywhere. But I can also split this into square root of 11 and negative 1. That we can do. Okay, and can you see, well, square root of 11, it doesn't have a simpler form, so we're just going to keep it as square root of 11. And this we can replace for I. So in this different scenario, or this hypothetical scenario, you can have the result being square root of 11i. Okay, and you can keep going, you can keep simplifying. So we have something like, I'm just going to keep going in here on the roots, right? Square root of negative 28. So what we can do in here is we're going to split this way. I'm going to take the imaginary component out first, right? The imaginary component out. So I know this guy over here is going to become I. And the square root of 28, I can further simplify into two roots, right? Or two factors of 28, such that one of them is the greatest perfect square. That's going to be 4 and 7. And I also have the square root of negative 1, right? So this translates into 2 square root of 7i. So just, if it's a negative root, just add the I in front of it. Okay, so for the problem that we were doing, this is going to be the final result. We don't really want to do anything else in this case for imaginaries.